Welcome to Data Integrity and Security. This is chapter number 2. We are covering database security in this one, and it's a basic information about a database and different aspects of it. They are talking about the hardware aspects or the specifications about the architecture and processes of a database. So there are a couple of things which we must be concerned about whenever we are using a database, since there are lots of things which are similar among all databases. So they are talking about the basic structure of it, how it works, what are the important features in it. So the objectives are: review the basic components of a database, define a database, and identify the basic components of a database management system. So whenever we are talking about databases of these days, it's a relational database or different kinds of databases are there. So we call them database management systems. Identify different database management system models and applications, and describe the architecture of Oracle, MySQL, and Microsoft SQL Server. Long time ago, it started from Oracle, which was quite successful, and at that time 50% of the overall market share of the database used to be with Oracle. Still, huge organizations are using Oracle based database management systems. Further, they have now their own enterprise resource planning systems, which are of course using Oracle database. Database, a collection of the data stored on a computer using a database management system. A DBMS application that allows others to search stored data. Goal is to provide means to manipulate, analyze, store, and retrieve the information. So it's not only storing the information, it gives you the option to search the data, because the main purpose of a database is to store information, huge chunks of information. And if it's not searchable, there is no point about it. Just like in an Excel sheet, you always use Control F and other functions in order to find the data in huge sheets. Here, with the help of a structured query, we can extract or get a customized report, whatever we want to get based on the query, whatever we are writing. It could be in one table, it could be in multiple tables. It can fetch the information from the tables and would provide you the information that you are looking for. Most of the applications which are working with database management systems are capable to show you the reports, but in a production environment, especially in academic environment or educational environment, there are lots of things or queries, reports, etc., which are required on day-to-day basis, where you'll have to write your own queries in order to extract some information. And now, extracting information is different than manipulating and analyzing the data. So in case you want to change certain things, or the course code or the credit hours of a course, it's literally difficult to go in each and every row and change the records, or to extract them in an Excel sheet, change it, and then import it again. If you have millions of records, of hundreds of thousands of records, it becomes very difficult. So with the help of a query, again, you can modify the records based on a field only in a database. So that helps you in managing the data. That's why we call them management systems. Example they are giving is a school library, librarian on campus or library, or a website online library acts as a database management system, because there would be lots of books in a library, and they need to maintain the information that one book, for example, the book for this course, database security, if it's issued to the students, it's one book but issued to lots of students, so they need to maintain information about each and every student who is using this book. Now, if we are maintaining records or writing the ID number, names, and the name of the book separately, typing it every time, there are high chances that they'll make mistake and have typos. If you have typos, as we discussed in the previous chapter, your reports won't be consistent. You won't be able to get the exact count of how many books has been issued to how many students. That's why in order to maintain the consistency of the data, we provide tables, or we create tables where we have the relationships and where we have the primary key or the secondary key of the tables. You might have covered it in the database tables that there is always a unique key for each. In a table, there is one unique key for a record. For example, if you have a table where you have all books, the book for this course CIT 226, there will be a special serial number for that, and it would be a unique for this book. So when they want to search that how many books are issued under this one book title, they can get exactly how many students are using this book. So that helps us in having a consistent data. Method of storing information in a database depends on the database type. Common components of a digital database management application is you have table, keys, and queries. Now the tables are the basic unit of storage within a database, represent unique and specific data objects composed of vertical columns and horizontal rows. Columns, also known as fields, and contains the general category of information with similar data. Rows, also known as records or tuple, holds the distinct units of data. Basic information, what is there in a column and what is there in a row. Columns can have different information related to different components of the data, and rows will have complete information about the things that they have. Now, as you can see in this picture, that they have a table of artists where they have a ID which is unique. We can say that that's a unique record in this table, and then we have artists with the name, and their different names will be appearing. Now they can use the same names in other tables as a foreign key. When we use these records, like record number 1, 2, or 3 in another table, it's used as a secondary key or a foreign key. Now, if you have the name, that's the row of it, and if we read it in the name column only, this is called a column, where you have the information about the users. And complete table with a list of rows and columns is called artist in this particular example. Now, key is single field or a group of fields used to identify an entry in a table, used to access and manipulate the records in rows within the relational database. Now, primary key field contains a unique label identifying a record or a row in a table. So for students, what would be the unique key for a student in an educational institution? It would be an ID number. ID number, or in your student records when you get admission, your unique key would be your national ID number, which identifies you that you are a unique person and you'll have the unique records. Since once you are in an educational institution or working in an office environment, you'll have an ID number issued by that office that would be used as your primary key. So your payroll, your accounts, your salaries, your benefits, your overtime, each and everything will go against your ID number. Primary key contains a unique label identifying the record of it. Each table has at least one primary key. Now, keys should be meaningful to the data being stored. Keys, for example, employee ID, social security number, etc., which is unique in its nature. A foreign key is a field within a table containing a label used for the relationship between two tables, often refers to as the unique entry of a primary key in a different table. So the primary key of one table, if it goes to the other table in order to build a relationship, is called a foreign key. Other keys are secondary or alternative key, candidate key, composite key, etc. You might have heard of it. And here they are giving you another example. They have two different tables having songs and artists. So the different artists might have sung different songs which relate to them as per the artist ID number, or the number which is appearing going as a foreign key to the other table. There you have name of the artists. Now, queries are searches initiated by users to retrieve information from the database. consists of set of variables or keywords formatted in a query language. Structured query language, we call it SQL, is used in this text to display the information in a report. For example, we are saying select title from songs, select the titles from the table songs, artist, songs and artists, where song and artist is equal to group ID and group name is equal to Madonna. So they are trying to find the information from the table songs and artists where the song artist group ID and group name is Madonna, and they'll be able to get that specific information. You can write any set of queries yourself. In Microsoft SQL Server, you have a query builder as well, with the help of which you can write or design the queries in a graphical user interface. SQL Server has it, but most of the professional and database solutions like Oracle and stuff, mostly people are writing their own queries in order to execute certain tasks. In organizations, if someone is the administrator of a database, usually they are certified for that, so that they can get in detailed training about a database management system like Oracle Certified Database Administrator or Microsoft SQL Certified Database Administrator, etc. Since MySQL, which is an open source database management system, it's available. They don't have any certifications for that, but it's really handy when you want to have online databases or transactions which could help you in your online stores and maintaining the information online. Just because it's free does not mean that it's not reliable. Huge businesses are using MySQL database, and it's capable of having huge transactions simultaneously taking place on the same database. Since it has a very small footprint, very light on a application server, you can host the application as well as database on the same server without having any issues. Now, database models represent the ways of the data is stored, determines how data is retrieved and manipulated. Four main kind of database models are flat, which is only having information just like an Excel sheet. Then we have relational, hierarchical, and network. Now, a flat model is a two-dimensional list of data entries. All data within a field are similar, or all data within a record are related to one another, similar to a sign-in sheet in a doctor's office, where you'll just come, you'll write the name of the patient and the time he's visiting. So none of the entries are consistent. Every entry could be different in this one. That's a flat model because it does not correspond to any other tables or fields in any other table in a database. Now, flat model disadvantages are multiple efforts, redundant data. It could be repeating, because if a person came twice or thrice in a day, it would have 3 or 4 different records. Whereas if you have a properly designed database, it would have only one patient and its timing separately appearing, that how many times he has visited in a day. Large marginal error entries must be made in exact the same way, or the queries will not return the exact results. Example of one user might enter Billy Joel and the Uptown Girl, and the other user would enter the name spelling in a different way and then would name the title in a different way, giving a space in between. Thus, if these kind of discrepancies are there, you'll never be able to find the exact information that you're looking for. Now, hierarchical database was popular in late 1960s and through 1970s. Uses tiers and parent to child relationship to represent the records and relationships similar to a structure to a family tree. Because for every record there will be a parent, and under that parent there will be children. Just like in computer and information technology, there will be one major, and under that major you'll have all courses. So all courses would be related to the parent, because we are offering all these courses under a program name. Same goes for other programs and other structures. One-to-many approach greatly minimizes the redundancy, There will be relationships like one-to-one, one-to-many, many-to-many, and vice versa. Now, one-to-one, one student can be registered in a one course at a time. For example, there is one course like this one. You can be registered in one course at a single time in a semester. You cannot add the same course over and over again and attending 3 or 4 different lectures in a day. One-to-one relationship. One-to-many relationship, one course can be offered to many students. Like we have one course, CIT 226, registered by many students. Many to many. Many courses can be registered to many students. In our college, we have lots of courses offered, and all students can take different courses. Now, model builds the relationship with one stem, no direct relationship made across the tree. Just like you can see that in artist table, there is Michael Jackson and Fleetwood Mac. They have different categories, and under that there are subcategories. So in the category top, or the parent, is artist. Now for album 1 and album 2 under Michael Jackson would be the parent of that table. So that's how it goes, and it breaks into the relationships and have their own categories. One thing to note is that once you have one parent over it, it's spreading under it, but it's not joined in between. So every table will have its own information. If you want to find information about Fleetwood or Michael Jackson, you'll write separately that I want to get information about Michael Jackson in his album number 1 and song number 1, or the categories which would be divided on separate basis. Now, a network model developed as a solution to one-to-many restrictive nature of hierarchical database models, tree-like structure using the tiers and parent-child-like entries to represent the relationships. Now, parent referred to as the set of which the child entries and member-child entries may be a member of more than one set. Advantages is many-to-many relationship, and they are easier to navigate. Just like in an artist, you have 2 artists under it, and then you have the categories under the songs. Now next is relational database. Common entries are stored within separate tables. Table given the unique names. Tables are unique and identified to build relationship among the entries. So if you have a student record in a student environment, you must have a student name, ID, blood group, and then the region or your mobile number, etc. So there will be a separate table about the blood group where we'll have all the categories of the blood group, which won't be repeated anywhere else. Every record will have a unique key, so we'll use that key in the table of a student record so that we are having a consistency. If we want to find that how many students are there with O positive group, we'll only go to the table with the group type, and we can find complete records of the students. Same goes for your ID cards which are printed. If you lose it or anything, all records are appearing in the main system where we can see that how many times the student has requested for an ID card. So you can find all that information using the relationship. Now entity, a person, place, thing can be stored in a database table, has the attribute of a relationship describing the characteristics, which defines the association between the 2 entries. As you can see that every table has an association with the other one, because we don't want to repeat the entries over and over again. If one thing is defined at one place, we'll be referring it as a reference point in the other table just to call the records from there. You might have seen it in an Excel sheet that if you want to import a field from a different worksheet, you'll just give reference to it, and that particular value will be copied from that row to the other worksheet. Now, object-oriented databases management systems allow storing and retrieving objects and complex data types as CAD files, artificial intelligence objects, XML, audio and video files, pictures, which could be stored in a database. Were not widely adapted in the release in 1985. They use specialized areas today to do that. In 1990s, relational database was expanded group of database types Middle group between the relational and object-oriented database management system, not widely used at that time. So now, if we want to add any information in the database related to the pictures or anything, we can store that information as a reference point. But whereas the picture would be saved somewhere on the storage device, but there will be a reference of it in the database. Just like for the student records, we can have a complete record of a student, and we can refer the pictures which are stored in the database itself of all the students, so that we can maintain the record in a single point. Now we have different relationships, define the association between the entries and bind them together. For example, one-to-one relationship and one-to-many relationships and many-to-many relationships. One-to-one relationship, there will be one-to-one pair. One-to-many, one thing can be related to multiple guys, and then one entity can be related to multiple entries can be related to multiple entries. Now in a database type, we have different kind of database type. Database type is determined by the data that will be housed in a different type of a database. For example, online transactions or online analytic processing for decision support systems, etc. Now, online transaction processing are the records or the entries that are made on hourly or weekly, not hourly, on minute by minute basis, or any sales which are taking place through the online stores. Since you know that there are lots of customers accessing it, buying things, selling things on a website, records, credit card details, transactions, and all that information which is constantly updated, they are using online transaction processing. Online analytic processing and decision support systems are the systems which analyze the data and then gives us heuristic reports about the data. For example, if you want to know the sales in a month, you can easily find it in a database. But decision support systems would read the information of the previous sales for the entire year, and then it would find that what was the months in which you had the highest sales, and in those months what were the days when people were very much interested towards buying the thing. So based on that, they will devise a strategy in order to have some kind of deals on their websites. For example, in a week, if they would like to see that people are interested more on weekends or during the daytimes, or what are the peak hours when they want to buy their stuff from the website. So these kind of information help them in making informed decisions. Online transaction processing database created for real-time storage and manipulation of data within an organization, created to use an active environment optimized to serve thousands of users simultaneously. Now it stores the data resulting from a large volume or the short transactions, point of sale systems, etc., which would save the information. Now whenever we are talking about online transaction processing, we must keep in mind that since multiple cash counters will be there in a sales environment, for example, in any hypermart, you have different point of sales, and every officer who's there on a cash counter would be keying in the sales and the records related to that. There would be times that two records could be updated or could be entered at the same time. So there is a row lock mechanism that if one user is interacting with that row, there will be a lock on it so that no one else can change the record. Otherwise, if both would be changing it at the same time, it becomes very difficult to know that who made the transaction first. So there are row level locks with the help of which they make the consistency and make sure that you can make the changes on it once one entry is written on a transaction. Now decision support system stores the large volume of historical data used to report, generate, and analyze, typically retrieve the data from the OLTP. Data analyzed in a business environment to meet the specific needs, for example, data warehousing and data repository.